start. Why?
Yes. Yeah, of course. So this is...
We are starting.
Okay.
As you can see,
Okay.
We're recording. So
completely
that, yeah. My idea was to, of course, to introduce you, and that's why I wanted Jovana, Professor Jovana Francus, to come here with me, because I think she would do the better job than me. All I can say is your name is Karolina Doka, right?
Yes.
And you're here with in Serbia for a couple of weeks already, right? And you are expert on NMR, right?
Yes.
And also you
less.
you connect NMR with forensics,
Yes.
and you held how many lectures in Serbia?
At least. Almost 10.
Yes, that's what I wanted to
but
say.
this 11th one is the most important. So,
Yes,
this one.
yes,
But
yes.
this is one.
Nothing so important that today.
This won't be the lecture. Yeah, this won't be the
This
lecture.
is the
I will just jump.
Yes,
Yeah.
I like it. I am Brazilian.
One of the reasons I don't like to introduce our guests is I always forget their surnames and stuff.
Yes.
And since you are from Brazil, we all know that Brazilian surnames, they're like 5 or 6 surnames.
Like a princess.
Yeah,
Names.
that's why Brazilian football players have their nicknames, right? So you know,
Dr.
Pelé.
Socrates.
Yeah,
So yeah,
it's like a trivial name for
Zico.
Zico,
it's like a
yes.
trivial name
Pelé.
for a compound. So you can use ibuprofen.
yes, like organic.
And then you lose your
name from molecules.
and die, right? Or you can just no. I don't think that this works, but
Okay.
this thing works. So don't worry.
Okay.
But you can use trivial name, and you can say morphine. I don't know, and everybody has a similar idea. Every chemist,
Yes,
at
yes,
least, has a similar idea. So, Carolina, welcome. We usually speak around 5 or 10 minutes before our guest gets the chance to say hi.
Yeah. I am observing this. I'm feeling this.
So you came here to Serbia to, like I said, hold a couple of lectures on NMR and forensics, and that's what we wanted to talk about today. Our audience, do you think our audience knows about NMR? Some of them, of course, because they're colleagues of ours. But I think that we have.
Yes, maybe we will just ask Carolina just to represent herself and talk about your institution.
Yes.
What are you doing, and some basic couple of words about you and your research. And later we will discuss about NMR forensic, because it's hot topic. There are a lot of people, a lot of audience who think that it's very interesting for not just for academia, but for general.
But everything that means forensic have a lot of attention of people.
Yeah.
Currently, yes.
So, okay.
Tell us something about you,
about your institution and what you are doing in Brazil.
Okay. My name is Carolina. Okay, you are correct. First response is okay. I'm from Brazil. I'm here in Serbia for my second time. I was here in the last year first. I stay in Novi Sad for 1 week, more or less. And so in that opportunity, I know some very kind people, and I was so well received here. I went to your chemistry department, your chemistry faculty. And so after this, I had one opportunity to submit one new project to stay for more time in some country abroad of Brazil. And I came again to Novi Sad. It's one special program that we have in Brazil to do new agreements, new collaboration, scientific collaboration with another universities. It's very important to us increase these relationships between our faculty and others. And I chose to come again to Novi Sad. And I'm very, very happy with this choice.
We are also happy because we heard a lot of good things about you from our colleagues from organic chemistry, that you already have very strong and good cooperation. So that means that our colleagues will visit Brazil.
Yes.
Cool.
In the same project, we submit one subject to when I came again to Brazil bring with me two researchers from here, Professor Giovanna and Professor Sanya. And they will come with me to Brazil to stay for 2 weeks, like me in the last year. And so I think that very, very good things will start again between us. And in the next opportunity, why not invite other colleagues to come to Brazil?
We accept.
Yes.
Brazil is very open to receive you.
Yeah.
And the very important point that it's we already have the one agreement between our faculties. They are signed, so it's open. It's okay to receive your students in Brazil and send our students to here to change some interesting things, because I custom to say that science we can do with in every place, with everybody we can choose. But first we need to have this good relationship between persons. So here in Novi Sad we have a very good team to collaborate, because the persons are so excited with science, so excited to good very good classes, teaching classes, podcasts like this is very interesting. The opportunity to live our science outside of our labs.
That's yes. We already discussed about that. I also met some very interesting people from Brazil with that passion for science. So that first in-person contact is very good for establishing a good cooperation on institutional level.
Yeah,
we believe in that.
We also. So welcome, and we will gladly visit Brazil, and we hope that we will have a good cooperation.
He means like
yes.
our colleagues.
Yes. In future.
Not just you.
Yes. Yes. A couple of hundred of us.
So you said you come from Brazil, but Brazil is huge country, right? So there is like states in Brazil.
Yes, we have 23 states in Brazil. It's a continental country, huge, really huge. I live in south of Brazil, more south, below São Paulo. I'm from Paraná states. I'm from Curitiba, the main city of Paraná, and from Federal University of Paraná, or National University of Paraná. It was the oldest university in Brazil, the first one. It's my faculty, you know. I'm very glad about it. And we have several departments and courses and careers, different careers. So this, it's important to say, this agreement between our faculties is not just to chemistry. It's valid to all courses, law, math, I don't know, pharmacy, medicine, engineering, chemistry engineering, or I don't know more.
There's also one guy, he is working on the Bioscience Institute. I forgot his name. He's from Manaus.
Yes, Manaus.
And Manaus is very, do you know
I was
that
just wondering
Manaus
when
is very famous in Serbia.
Yes.
Do you know why?
Because
I call this guy
IT
no. I call this guy I call him Mr. No.
Yeah, it's comic book
because
character.
in 80s and 90s there was a very popular comic book called Mr. No, and he was from Manaus, Brazil, and
he lived in Manaus.
I showed him that comic book, and he was amazed. Wow, this is a real national theater in Manaus.
Yes.
So I called him Mr. No.
I was
so
just wondering
Mr. No, he's working.
But it's true.
Yeah, so Manaus in Serbia is extremely famous. He was amazed, you know, about Manaus. Yeah, a lot of people know that.
It's an Italian comic book and Italian publisher, but the character lived. That character, Mr. No, he lives. He's still. I mean, he lives in Manaus.
We'll show you that comic book that says that Manaus is popular.
It's adventure.
Was popular.
Oh, good.
In
Very
new generations don't like comic books.
Yeah, well, they do, but they like manga. They like manga.
They like manga, but yes.
Yeah. So
interesting. I never stayed in Manaus.
Okay,
because it's more or less the same time to travel to Manaus that came to here.
Okay. Yeah.
Because the plane of flight, I don't know, and it's very close to the Amazonia. So I think that you talk about Amazonia. I never imagined that one cooker man make Manaus so famous here. Good.
It's like some kind of like an island of civilization in the forest, in the rainforest. It's really weird, Manaus. Yeah. Okay, so you came here as like I said, NMR expert, which you are, and you already taught some tricks and stuff to my colleagues, to my young colleagues, which is awesome. So they already benefited from your stay here. So could you tell us something about NMR? What's
I love
NMR?
it. Yes, NMR is a very dangerous science because when you know something, you feel in love with NMR.
Cool.
So be prepared.
Okay.
NMR is one very powerful tool to discover which kind of molecule, organic molecule we have in some sample. And it's indifferent which kind of sample that we have in blood, in water, in foods, in some new materials. When we need to characterize something new, especially new, we need to use some tools to do to take the information, the chemical informations from this material, from this food, from this new medicine, for example. It's necessary to take the identity, quantitative informations and qualitative informations, and the NMR is one of the best tools to do it.
Cool. Why? Does NMR give us like a formula? So you press a button and you get a picture of your mouth. Is it?
Yeah, like in TV shows.
Yes, like CSI. You put the sample in one side of equipment.
Is it so simple or it's a bit complicated?
Of course not.
Or much more complicated?
No. Today is not so complicated. And a few years ago, we have other spectrometers and other techniques to do it. And one very common problem in Brazil, for example, I don't know here, but in Brazil, it was not so common to have one machine like this because it's a huge machine and very expensive machine. So when students need to do this analysis, for example, it was very common to send your sample to a bigger university to acquire these experiments. So your supervisor tell you for sure, keep attention with the sample. This sample needs to be very pure and perfect sample because you don't have another chance to acquire this experiment. And this creates some idea that NMR is very hard, very difficult to do. It's necessary to have some so much pure compound to acquire this experiment, but it's not true. Today, we are working to change this culture and just show the powerful that you have to analyze everything that you want in the same sample without any kind of purification. Because especially in forensics, because you will have one non-target search about this molecule. Of course, your response will be not the molecular formula. You don't have the picture of molecule inside. You have like one graphic with a lot of information that you need knowledge to recognize it, and so it's necessary to have good classes of NMR in your bachelor studies or in your undergraduate studies.
Awesome. So you said it's one of the best methods to identify.
I think so.
Okay, but maybe we should mention other methods used to identify some compounds.
Of course. Our philosophy is not to prove that NMR is the only technique that you need and the other is not important. Not this, of course not. But NMR will give us the information between the atoms, and we will have the correct position of these atoms. We don't have this information from one FTR, for example, infrared. You don't
He's
have
the infrared guy. I mean,
yes.
among other things. Yeah.
Okay.
Yes. I
You
know
have
that.
the information about functional groups inside
Yes.
that molecule, but how the
Structure
atoms are
is different. It's
Yeah,
more
yeah.
complicated. That's why we need NMR. Yeah,
yes, to determine the structure, the correct structure. Okay, we can acquire one mass spectrometric analysis. Okay, but if you have the only difference that you have in the molecules, the position of one nitrogen, for example, it's very hard to determine this with mass. So you need this information, and the only technique, the only tool that will give us this information is the NMR.
Also, there is crystallography, right? But crystallography
yes.
has
Need to be a crystal.
inherent problem. Yeah.
Yes.
So yes, I'm playing dumb guy. But yes, definitely the NMR spectrometer is that
Yes.
the machine the machine
we
is
acquired.
one of the most important. I think it's the most important thing on our floor. I was brought up like a organic chemist,
Yes.
and it's the priceless thing. It's the when
It's not possible to do anything without.
Yes, when it breaks, God forbid. But sometimes it breaks. Then we have
lot of times.
then everything stops because that's where our focus is. If we synthesize
For
something.
organic synthetic chemistry, it's
Yes.
the main tool
Yes.
for
If we
structure.
synthesize-
Without NMR, no actually, yes, you can synthesize, but no characterization.
Yeah, you don't know what you
Totally
get.
no.
Yeah.
And we are working a lot in our faculty to increase this world around the NMR, because we attend at least 18 PhD programs that are not organic, but they use a lot of NMR. Because inorganic guys will need, it's possible to use the research about new materials.
Definitely.
We will use medicinal chemistry, need to
Definitely,
use
definitely, yeah.
natural products, need to use.
Yes.
So if we are thinking about new compounds to treat some disease, for example, we are searching about a new compound or from natural, from some fruits, some plants, or some like this. We need to discover what molecule we have. So you need NMR. We are working to increase these borders outside of organic, and it's very important to our departments, for the heads of our departments, our super directors from faculties, or the companies outside the faculty recognize this, because without NMR we don't have advanced
Also
technology.
find the same here in field of spectroscopy.
Yes.
We need that multidisciplinarity approach, because we are using infrared spectroscopy in soil science, in polymer analysis,
In agriculture.
in medicine. So
Yeah.
that's good. We have that kind of expansion of research and that networking. So it can be benefit for all of us, not
Yes.
just for research
Yes,
scientific
yes,
community, locally and globally. So
We need
That's good approach.
custom to say in Brazil that the machine will cost the same working or not, because NMR have one characteristic. It's like a huge imam, a huge superconductor, and when we put magnetic current inside, we never more can stop this.
Yes.
It's not like one light that you
liquid
turn on
nitrogen,
and turn off.
liquid nitrogen and argon is required every week.
You need to
Yes.
use it. You need to use it.
Yes.
The
And
more you use it, the better.
Yes.
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 But you mentioned when we started talking about the NMR, you said it's a really valuable tool to identify organic compounds. And later you said there's also like chemists that do inorganic chemistry and stuff that can also use NMR. So basically it's not even limited to organic compounds, right?
Yes.
So what's the main principle? I mean, I know it's a hard question, but what's the main principle? We didn't mention NMR is an acronym, right?
Yes.
Nuclear
Magnetic resonance.
Yes. So nucleus, right? So some elements, right? Some elements can be used and visible, can be visible in NMR. So could you just?
I will try. When you have some molecules that whatever, we will have atoms. Inside of these atoms, we will have electrons and atoms. These atoms will have some inner characteristics, like one identity of this nucleus, and some of them will be active to the effect of resonance. What is resonance? We can imagine this nucleus like one party dancing to another directions in this room, for example, in randomic mode. When we put this sample inside the NMR, inside this magnetic field, they will align it. More or less half of this nucleus, more or less half of the guys in this party will be aligned in the same direction that this external field, and another half will be aligned for the opposite direction. And so these directions for the same from the same or opposite will have difference in energy between them. So the effect that we will measure is input and another source of energy, like one pulse, and this pulse of energy will align that guys in opposites inside in the same side with lower energy to the higher level of energy. So we will improve this nucleus, spins nuclears, to be in the higher level of energy. When this external pulse will be stopped, they will return to the equilibrium system, to lower level of energy. So we are measuring this difference in energy between these nucleus, and this difference will be related with the chemical environmental of this nucleus. And so because these characteristics, we could to see the connection between these atoms.
Inductive steric effects.
Yes, inductive, sterics, and electronic effects.
So basically, we have some kind of like a number of peaks, right? Some like a month. Sometimes
like
it's like sometimes it's very complex.
Lines.
Probably, yeah. And that's the all of these peaks are probably a signal of some kind, some type.
Of
yes.
Chemical bond.
Yes.
If and specific, we have hydrogen and carbon.
That's what. Yes. Tell us.
We can have hydrogen, carbon, nitrogen, phosphorus, as lithium, aluminium,
nitrogen 15.
Nitrogen 15.
Not 14.
Not 14. Carbon, for example, is not the carbon 12. Carbon 13. Because the characteristics, natural characteristic of that nucleus, that isotope.
So that's why you said. That's why isotope. That's why you said first. You said organic compounds because it's most I think usual.
Most common.
Most common spectras are proton spectra, so it's hydrogen and carbon 13. Yes. Which are the elements that are present in every organic compound.
Yes.
So basically, every organic compound should be visible to NMR.
Yes.
Yeah, that's awesome. But like I said, like you said, there are other nucleuses, or like other elements or isotopes of elements that can be also recorded. I don't know if we did some experiments with those more exotic.
I was trying to perform experiment with nitrogen 15 because my PhD was about hydrogen bonding in amide molecules. So there was idea we have an 15 probe, but we never tried it because this peak is about 6 ppm and it requires a lot of scanning because it's wide.
Yes.
But who knows? Maybe one day.
Could be another kind of experiment with
probably there are a lot
double dimensions, HMBC. Probably so we will have like a soap ladder with the different kinds of experiment that it's possible to acquire from NMR. And another interesting thing to say that we can have experiments from the solution when we have one sample and put in some solvent inside.
It's most common.
The most common, but we can
you do
acquire.
solid?
Yes, we
Lucky
can.
you.
Yes,
That's
yes. And because these
very powerful technique.
Yes, especially to
Solid
new materials.
NMR, it's extremely powerful.
Yes, it's another universe.
Yes.
Yeah. So you can even work with solids. Awesome.
Solid, and we have one special probe now, a semi-solid material to. It's possible to acquire, for example, let's see one strawberry. You are searching for some chemical compounds in that fruit, pesticides, for example. We can put directly one part of strawberry and it too.
So it's basically one step, and the other step will be
no sample preparation.
No sample. So you can basically theoretically, or maybe not, you can like scan a person. Could you scan a person with NMR?
In the hospital, yes.
In the hospital, right?
Yes. Not NMR, this is MRI.
But the principle is the same. It's the same principle.
Same principle.
Yeah.
Have you already acquired one NMR from you? Or MRI from you?
Unfortunately, yes. I had an injury. I had an injury. Yeah, I needed to spend some time in this.
And I'm thinking when this happened, I'm thinking like I was inside of tube of NMR and go inside.
Now you are sample.
Yes, I am the sample. And one time we received one call from some people ask us if we receive, I talked about it in the lecture yesterday, searching for us that you receive, if we accept to do NMR by some special kind of health insurance in our lab. And you need to explain that our NMR is not the same that the NMR of hospital. But the principle is the same.
Yeah, the principle is the same. So
we make the same in the hospital, but two molecules.
Yeah. So, and of course, in the hospital, you are the sample. You are the cuvette.
It's very, very important. You are talking about nitrogen. Let's thinking about the Nobel Prize of this year about proteins.
Yes.
And to recognize the structure of proteins is very, very important to acquire special experiments from NMR.
This is
600 megahertz.
That's awesome. That's awesome. Information, because we are used to, when we talk about proteins and their structure, we are for example, I usually go to PDB, protein data bank, and like download stuff from there, and it's awesome, but it's usually crystallographic data. But like you said, there's like it's like routine stuff to record and publish
and to
NMR.
And to understand how one compound can interact with this protein. So studying disease, new medicines, for example, is very, very important.
I would like, tell me.
And of course, there are a lot of groups or research groups working with this in the world. It's completely different that the work of organic synthetic community use. It's another special experiment. So NMR, I custom to say NMR is like a huge family. We can accept everybody.
I think you said protein structure. I think that the name of the guy is Baker, the surname Baker, because they were like
Nobel Prize winner for this year.
Yeah.
Yes.
Three guys, but
one
two
of them is Baker.
Yes, one of them is Baker. I think he was working with the synthetic proteins. I think that's what's so are there some like not I don't want to say bad things about NMR, but are there some problems with NMR, like I don't know, price or something like that?
Well, okay, I don't think so. But of course, the problem is the quantity of money that you need to buy a new machine, and it's not just to buy, because and of course the price is very high, and because this we need to show for the faculty that we have a huge community using this equipment. It's important because we explore the multidisciplinarity, but it's necessary to have every week input again liquid nitrogen to keep this superconductor with lower temperature, to keep inside of this superconductor liquid helium. And liquid helium is not renewable; it's a finite
resource. Yes.
And it's a big problem. We don't have yet another material to keep this superconductor really good isolated of the other.
So the machine needs to be cooled down, right?
Very low temperature. Yes.
Also,
do you know that Pavle Savić constructed laboratory equipment for liquid helium with Irena Joliot-Curie
to recover?
I know he worked there, but
So just one hint about Pavle Savić, famous Serbian scientist who worked on liquid nitrogen, because at that low temperature, there is no viscosity at all.
Yes.
So
special
equipment is needed for such a low temperatures. Yes. That's why is maintenance of this equipment is so expensive.
Yes.
How many machines do you have at your university? NMR.
Yes, in in the chemistry faculty we have 3. At 3 today, 3.
We only have 1. Okay.
But you have a new one. More new that hour. Our 400 megahertz has more than 20 years working. So it's very old. But and the problem of this is that we don't have more parts
Spare
of this.
Parts.
Yes, to
buy. Is it Bruker?
Bruker, yes, the same.
But there's one hint. The similar situation in spectroscopy community, but there is some guys. I cannot say where, but
yes, we don't name.
They can provide.
It's a very large family that help each
so
other.
If you need some
for a certain amount of money, right?
It's like one big garage. You can put some parts of one.
That's important because we all this instrumental community have similar problems.
Yes.
Because
without this help of our colleagues, we will die.
Because producers and big companies that produce such instrumentation, they are expensive. Okay. And
but sometimes they stop it to produce that we need.
Yes,
we don't
actually,
more.
That's a special thing with NMR, machines, because
not just with NMR.
But I agree. But in NMR field, right? You had a couple of big names, like it was Varian, right?
Yes, Varian, Oxford.
Yes, and Agilent. It was. I think he
was a player.
Varian, right?
Variant,
right. Yes.
Bruker, yes, no.
Yes, Bruker, of course.
Yes.
The main is Bruker.
Yeah,
but Shimatsu, yes, no.
No,
I don't know.
But you had for chromatography and others, but not.
I don't know. Just asking.
Yeah, but you had some kind of rivalry. You had some kind of competition. Now, not now, but when
it's
Varian,
good have the competition.
It's good because like 10 years ago, when Varian went out of Agilent went
Agilent,
we don't want
Varian.
to but they gave up on NMR. You just only 2 players remained, and one of them, Bruker, I think owns, I don't know, maybe 90% of the whole market. So I don't want to say monopoly, but basically, if it's not monopoly, it can turn out to be a monopolist. So they can dictate their. I think the other manufacturer is Japanese. It's Japanese Gel something. I don't know.
Gel.
Maybe it's a good moment to send the message for the Bruker.
Yes, Bruker.
Support our podcast.
No, but when you
we will be thankful if you provide a couple of NMR.
But the thing is, when you own 90% of market, you will
get free ads here in our show.
Yes, you are talking about a lot of Bruker. Yes.
Okay. Okay, so you said you had three machines.
Yes,
but
3 machines. This 400 megahertz is a very old machine, so only the guys that work with them is the researchers that work with NMR, and we have a team of students working with this and acquiring the experiments to the other students. The other equipment is a 200 megahertz, dedicated to PhD and master students that receive one training to operate. They will acquire your honor expectors, because we believe that it's very, very important to your formation, to your knowledge in your PhD studies and master studies, to keep in touch directly with the machine.
Actually, it's a craft.
Yes.
My
Tips
thesis
and tricks about
my thesis advisor, my mentor, Professor Popsalin, Mirena Popsalin, who is I don't know if you talked about her during university. Did you meet?
No.
Too bad, because she's like a old school master, NMR master. She has, I don't know, maybe 30 years or even more of experience with NMR. So she would agree with you wholeheartedly. She was like, that was her primary like idea. Not only like the importance of NMR, but also importance of students getting their hands not only dirty, but being in touch, like physical touch with
we are using our old infrared spectrophotometer for that purpose.
Yes.
And
It's with the
the
same
exercises just give them to replace the detector, to change the laser, to change the optics, to perform some experiments, and that's
we can
very
have
important.
problem with this, of course,
Because they need that
But-
experience, that
Yes.
working experience, not just theoretical.
we are not one company to just report results. We are forming persons, so this is very
But
important.
let's just talk about forensics. We are waiting for that. Give us
So
something-
what's the connection
something-
between NMR and forensic? I mean, we can think of some.
how can we
connection,
use
but-
NMR in
yeah.
forensic science, and give us some examples,
Yeah.
something mysterious, bloody, and
Yes. Wow. So
probably you have some good stories about
Yes, of
from
course.
forensic analysis, and people love that stories.
yes. This is
CSI
start-
Brazil, CSI Paraná.
CSI Paraná. Really, we have in Netflix one TV like CSI from one real case from Brazil. The name is DNA of Crime. It's in the Netflix. It's possible to
Okay.
to search about.
Yeah.
But we have in NMR at least three special things that make this tool very good to the forensics. The first one is non-destructive technique. So we will have your sample after you acquire your experiment again. It's necessary to the forensics. The second one is in the same experiment we will have qualitative informations for the identity of the compounds, and quantitative is possible too.
What is an
Yeah, if
And
it's
about
there, is
amount.
it there or not?
Yes.
And if it
How
is,
much?
how much?
How much?
Yes.
And the other thing that we're talking about a non-targeted search. We are looking for every compound that you have in the sample, not just for one. For example, if we have one problem with milk, adulteration of milk, we are searching for one specific compound. Okay, probably we don't found it, but we could have another. So in comparison to the other techniques, probably using chromatography, GC, or
cool.
HLPC.
HPLC?
Yeah, HPLC, yeah.
Yes.
Yes.
Sorry.
Yes.
But probably if you are searching for one specific compound and if you don't have this, and if you don't have standards to compare with another, we don't have response. We don't know what you have there. In the NMR, you don't need to standards to compare, because this connection between the atoms to do that molecule is very specific, and you can compare with literature, with a public database, for example. So these characteristics make the NMR so important to apply in forensics. In forensics, you never know what is the question. The next question. You need to be prepared to respond everything that you will receive. In Brazil, we don't have police guys dedicated to research inside the police.
Okay.
They are doing your work, going to the criminal scene, taking the vestiges, the things that from that locale, going to the lab to analyze these. But if they don't have methodology to analyze that sample, they don't have time to search or research about it. They don't have time enough to develop new methodologies, for example. So because this, in Brazil, the collaboration with the universities are very, very important, because in university, what do you have? What do you do? Research,
Yes.
a lot of research
Yes.
in several areas of science. And because this, in Brazil, we have very good collaborations with policies, not just in my faculty, in all faculties in Brazil. We are working together with the policies in not just in NMR, with infrared, with...
We also have experience, we are included, our group was included in a couple of cases, especially in FTIR analysis, because our colleagues from police, they need fast
fast
methodology and quick and quick response.
Yes.
Why?
They don't have time.
Yes. So sometimes it gets complicated, because in some samples you have very complex matrix and matrix effects.
Yes.
I was a couple of times in a couple of cases, so they required a fast answer. Do we have that substance in that matrix? I said, I'm not sure about that.
Yes.
Because sometimes your signals are overlapped.
Yes.
And
do you need more than one technique to respond to you?
Yes.
Yes. It's common.
And do you have some kind of your local spectral libraries?
Yes.
And how can you use these, your own databases? For example, because all the samples are specific in some way. Samples of water, milk, blood. Yes. Do you prepare your own databases which helps you to obtain faster response?
Yes, with the time, we are creating.
Building up.
Yes. Increase the number of samples that we analyzed. In another situations, the policy have some standards, and so we acquired the NMR. We acquired NMR experiments to have these signals inside. In the other situations, we don't have anything, so we acquired this experiment and go to the literature to search about the compounds. And in this case, of course, we will need a little bit more time. But it's important to say that in Brazil, unfortunately, we have a lot of examples to study forensics, and not a criminal scene cases. We have adulterations and falsifications in foods, in drinks, with agrochemical pesticides, for example, that came to Brazil from our borders. We have huge amount of
samples.
Yes, borders. And in Paraná states, we have the International Postal Office that receive all the things that the Brazilians buy abroad of Brazil. First came to Curitiba, to Paraná, and after will be distributed to the Brazil. So it's several doors for entrance of illegal substance. Do you know?
Also, one example: 15 years ago, maybe we had some samples, and because we had a cooperation with our policy department of ecstasy, methylene dioxide, methamphetamine, but from two sources. First was synthetic, and second was natural ecstasy. I first time obtained by the sassafras oil.
From sassafras, yes.
Yes. So there was a idea to make a spectral library to see the sources of ecstasy. Is they from, from...
This is information from intelligence.
Of course.
And because of this amount of compounds that will stay in the synthetic, it's possible to find the source.
Yep.
The information is there in the sample, but with other technique we don't see them.
Yes, that's why you probably need a response from 3 or 4 different techniques to obtain final result.
Yes.
3 or 4 techniques. In which way you?
Mass spectroscopy,
cool.
NMR, infrared.
Yeah, that's one thing we didn't mention. Yeah.
Gas chromatography.
Yes, gas chromatography. But if you are looking for just the main product, for example, MDMA.
Yeah.
If you are looking for just for this compound, you see, okay, it's MDMA, but in NMR, we are interested too in the other little compounds present
you have
inside.
Better resolution that you have deeper insight in the structure that spectroscopists like I am.
Yeah.
We just say
yes or not.
Maybe, yes.
But that kind of information that will tell us which guys produce that from the contamination inside, for example.
So it's like a traces, some
probably,
very small amount.
Yes, small amount. Probably you have, for example, 30 samples to analyze. And
15 is from Manaus,
and
10 is from Novi Sad.
Yeah.
For example. Yeah. You can observe this. This group came from the same place.
It's like a fingerprint. Combination of traces, like a fingerprint.
To find the common local characteristic, do you use some machine learning, artificial intelligence algorithms? Because it can be useful in
chemometric tools.
Yes, in chemometric tools, in classification and quantification. Because this is normal to use it, because especially when you have a large amount of data, diverse data, how to find the patterns.
Yes, you need
unsupervised pattern recognition.
Yes. And so you have, look, again, we are talking about the relationship between different fields of the science. And so, especially in forensics, we need to talk with our colleagues from the other fields. Definitely. We need the help of each other.
Yeah, I was wondering. I went yesterday. I saw that you guys, you and my colleagues from our group, you were preparing some.
Yes. I taught some histories. Yeah. We are in Brazil, for example. We have one of the most famous cases of adulteration is from vegetable oil. We import, of course, and produce a lot of olive oil to use in restaurants, in our houses, for example. And again, in Brazil, we have a lot of problems with the falsification and adulteration of this vegetable oil. In Brazil, we analyze a lot of samples, and the major adulteration, the most common adulteration in Brazil is with soybean oil instead olive oil. And we can use NMR to analyze this very, very fast. It's just take the experiment and see to the result. It's possible to analyze this from the omega-3 quantity that we have inside of the sample. If the vegetable oil use it to put in the bottle instead olive oil is from Argentina, for example. Sorry, Argentina, but it will be sunflower.
We have same problem with Bulgaria, so sorry.
I don't tell this. But here we analyze. We decided. Let's see what happened about your vegetable oil, and we started acquiring the first forensic NMR use here from Novi Sad and analyze olive oil and sunflower oil. and of course you have really sunflower and olive oil.
Yeah.
It's
Well,
okay.
yeah, that's one or two samples.
Yes,
right?
yes,
yeah.
yes.
But it's cool. Yeah, I kind of wish maybe you found out some like.
But now the guys are trained to acquire new experiments.
Yeah,
You
we could
have,
do,
you
we could
can
do
have,
that. Yeah,
yes.
that would be awesome.
We tried the same with honey.
Yeah.
You have real honey.
Honey, it's very, very interesting, very important here because I know some honey producers and they claim that there is a lot of fake honey in our market, but I'm not sure about that. So for us, it's very important to have well-established method for
No, you have.
classification.
Just go to the NMR lab.
Thanks for that.
But
Very important.
It sounded weird to me, like fake honey. What's the fake honey? Probably
Because it
something
contains
which
sugar.
not
Sugar,
made,
yes.
Sugar
which is not
from
made-
sugar, other source of sugars, and not the real sugar produced from bees. And it's honey is a very complex matrix to analyze by the other techniques. So if NMR, we just put 3 drops of honey inside the tube, put deuterium oxide or water, deuterated water inside, and mix them and put in the machine. Just this.
And so you get the answer yes or no.
Yes.
Yeah.
If the sample have saccharose or not. Saccharose is not from natural honey.
Which was the best NMR apparatus machine you ever saw?
Very hard question, but we have 2 directions, and from one side we have 1 gigahertz
Okay.
of machine.
Yeah,
for
we're
example.
talking about hertz, like megahertz, gigahertz. So the more the better. The more?
No.
Okay.
It depends of what your field of research. If you are looking for proteins and disease and study disease in human body, for example, you have 1 gigahertz experiment. And in this case, these equipment that are probably in the huge center of research and hospitals or something like this. But if you are looking for other things like in the faculties, you can work well with 400 megahertz or maybe 600 megahertz, not more this. And the other direction is this: it's go to the lower field, because with lower fields probably you don't need a lot of liquid helium and nitrogen. For example, one equipment, the third equipment that we have in our faculty, that is a Fourier 18, is one benchtop NMR that acquired a spectra that is in two dimensions, and we don't need nitrogen or helium. It's just light, electricity.
Wow.
And we don't need nothing more than this. And it's possible to acquire experiment without deuterated solvent too. But of course, we don't have the same resolution, the same separation between the signals. And we are working to recognize it's like take one picture with different pixels.
Resolution.
So some cell phones will be better than
cheaper
others.
cell phones give.
Yes, we don't need to tell the names, because this guy have a lot of money. We don't need to use your podcast to announce your company, but it's more or less the same. So we are going to. I think that we are going to the new technologies to have better spectrums from lower fields.
Yeah, it would be cool maybe to train AI, maybe to use those lower resolution but cheaper spectra. I mean, from cheaper machines.
Yes.
And to combine that would be awesome. So you could
Bruker had this, of course. They developed this machine to apply, especially in forensics, and they validated the relation between the bigger and smaller, so they could be connected between them. So you can think one central laboratory working with a huge, big machine and strategic lower fields
of course.
in your country.
Both worlds.
Yes, in airport and borders or something like this.
Yeah, I even heard the opinion when we talked about resolution and that frequency of the NMR machines. Somebody said, yeah, it's good if you have like 400 megahertz compared to some older versions weaker. But there's a problem if you have some kind of trace compound, if you have some kind of impurity, then it's more visible.
Yes.
you have better machine.
Yes, better, not sample.
You get peaks that don't belong there.
This is a question of Professor Chanadi. Professor Chanadi is one of the legend of NMR. And the first question, because on his exam was, oh, yes, but are you sure? First step, maybe you just have some impurity. That maybe that's not your signal.
Yeah.
Because you said that you're using deuterated water, because water contains protons.
Yes.
And it can overlap all your peaks and you are completely blind. That's why we are using deuterated.
Yeah, we'll need to mention that
solvents.
whole thing.
I have a lot of deuterated solvents.
Yes.
Yes.
From
good information.
Sacle from France.
Yeah.
And they are expensive also.
These are some old ones, right? So some old.
Yes, in some metal closed containers.
You are very rich.
Yes.
That's what I wanted to mention. So one of the let's say problems with NMR, working with NMR, is deuterated solvents.
Yes. Because the experiments are measured, our measures are taking from hydrogen, common hydrogen.
Usually,
yes. And this is the signal that you could observe. If you use one common solvent, that this solvent will have 2 hydrogen, and for more, even that you use a high concentration, you have always more solvent that sample inside the tube. So the bigger quantity or the most quantity that you have inside of that sample will be the signal from solvent, not from your sample.
So you have a huge mountain of signals.
Huge amount of signals from solvent, and you don't see the signals from your sample. So because these we use solvent that instead hydrogen are linked to deuterium. Deuterium is another isotope from hydrogen, and so this deuterium will have different behaviors inside of NMR. You don't see the signal from the solvent, because the solvent will be made not with hydrogen but with deuterium. So you don't see deuterium, you can see
because deuterium
hydrogen.
Have a pair number of
it's
nucleons.
different.
Has a different magnetic moment. So in case of resonance, there is no resonance between.
About NMR.
Yes, because I'm from physical chemistry.
Yes.
This is the part of but just this part of magnetic moments and these quantum effects of two projections of. Actually, you have just 2 possible projections of vector of magnet. It's little magnet.
Yes,
it can be projected on the field of the magnetic field in 2 ways.
Yes, the hydrogen in the case. And
in case of hydrogen, yes.
And the deuterium will be 3.
Yes, because it's different. So
yes.
And the problem with deuterated solvents is that they're expensive.
Yes, because they needed to prepare it in the lab, synthetic.
Which makes me wonder. I've heard that sometimes scientists combine like HPLC with NMR. Like NMR, they use NMR like a detector.
Yes.
But if it's flow system, then it would be
it's a dream.
There will be a lot of expensive. So maybe they have some kind of recycling.
Yes, I think.
Yes, I love our podcast because here we discover some truths, and I'm so happy because you're here and you're sharing your experience and your problems, and also we usually send a message for our audience to say how important science is and show some respect, please. I'm not writing.
For example.
Yes, for example, just see how much effort is included and involved in work, not just in Brazil, in Serbia, worldwide, to produce something to realize, to find something to keep this world health as possible. So a lot of people, they know about, you guys, lab rats.
Yes, but they don't have idea that the hard work inside
that we are facing, and that support of local community and global is very important.
Yes,
that's why we have that kind of networking, because I understand your problem, and this is a good way to
brings me to one
together.
of my last questions, and that's did you have any problems with your work and the I mean, sometimes you find out probably some not very some very interesting you find out some very interesting facts about, I don't know, some forensic case. Did you have any problems? Did you maybe needed some kind of
I like it very much of the problems.
Okay.
Yes. Why? Because from the problems we will find a new response.
Okay. Yeah.
Always.
Yeah.
But I have one a little bit not funny, but interesting situation. Yeah. In Brazil, we have one special corporation inside the police that work with dogs. Dogs that are trained to use your noise to recognize vapor stuff. In the airport, drugs in the airport, for example. And that space that receive international service post, the dogs works inside there, for example. And that guys need to make several training with that dogs, and they need to use some materials that we can supply for them. I can say the substance, for example, methyl benzoate.
Okay.
It's one of the first parts of cocaine that we lost in the natural degradation of that molecule, and this compound have a very low pressure, vapor pressure, so they will be for the
so they're volatile
and first.
Yes, and they're, if I understood correctly, they're metabolites of
yes,
okay.
yes,
Okay,
yes,
okay, okay.
metabolites,
Yeah.
yes,
Cool,
thank
cool,
you.
Cool.
And we prepared methyl benzoate in labs classes, for practical class, for example.
It's a simple molecule.
Molecule, and it's used in a lot of things. It's not a talk. It's not.
It's ester, actually.
Yes, one
it's
ester, and use it in food companies, for example, in a lot of things. And okay, we prepared this and put in silica, and they are absorbed outside of silica, and they can use this to put in your bag, for example, and train the dogs. Okay, but these guys have another problem. They arrest some samples from streets in Brazil and need to know if that samples are really drugs or not, if they are poor or not, if it's possible to use that substance to do the training with dogs. And ask us, teacher, or they always name it us like professor, could you acquire some NMR experiment to see if the sample could be used to train the dogs? Okay, we can. Please give us the sample. I am waiting for a small amount of sample. Together with the guy of police, of course. And in reality, they came to faculty with two big box, like produce, like a bazaar, like your natural big, huge box. Yeah. With a lot of cocaine in one box, several operations. More or less 10 operations. One of this size, like one bar, big bar of cocaine, and I'm, oh my God, I will be
they didn't know the scale of your
they
methodology and stuff.
Yes, he don't have any idea of how.
You should be quiet.
Yeah, but you need
that's not enough.
I need 10 milligrams.
Yes,
you should tell him, that's not enough. You need 10 times more.
In another box, several different kinds from cannabis.
Okay.
So when I saw that two guys from the police go inside the faculty with two boxes of drugs, I really don't imagine, oh my God, I will be arrested, I will be hired today. Yes. I immediately came my student, our student that worked with this, and please give us Eppendorfs. With the guy of
you
policy
watch me doing
together
it.
with us, watching we are doing. Please
couple of Eppendorfs and go.
And take these Eppendorfs and go back.
Go
Leave this
and
to me.
you.
Yes, I will give.
You guy from the policy, please go away from here with this sample. It's not possible. It's not allowed. Okay. And now they understand how much samples that we need, and in this case that we need acquire some experiment. They came with us together with the sample, wait for the acquired experiments, come back with the sample again to the policy, because it's not possible to keep these samples inside of the faculty.
Which is also thing to say. I don't know if we mentioned it. The sample size for NMR and the amount of compounds
It's very, very low.
Very, very, very small. So
Cuvette is
and that's solution.
Yes.
That's solution.
Yes.
for solution for
Yes,
solid
it's like
sample is
one
also-
pen, like
Yes,
this,
yes.
and we put 500 microliters inside in the total volume of sample.
Yeah, and deuterated solvent. Yeah.
No, the 500 is the total. We will put 10 milligrams in maximum. Could be 1, could be 5 milligrams inside, and put the solvent and just this.
Yeah.
Cool. I think we can easily go to the end of our episode. Maybe if you told us what's the it's a hard question. It's but what's the main impression from this stay in Serbia?
This is not the hard question. It's the best question. Stay here. It was amazing experiment for me. Really, it was my first time, so long time outside of my house, outside of my country. I have 2 kids. I don't mention it. And yes, kids, mom is going. Mom are going. Is going. And it's very hard to stay far away of them, of course. But the experience that I lived here, it's a standard point for another kind of work in my life, in my scientific work, of course. And I felt here like I was in my home, really. Awesome. In faculty, I was so very well received. I was in other faculties from Serbia. I was in all public faculty of Serbia.
That's what we forgot to mention. You visited Kragujevac, you visited Belgrade, you visited Niš.
Yes. We are in the one pharmaceutical company.
Galenica.
Galenica. We are there. I was in Brazilian embassy.
Cool.
I never imagined that I could stay with one event or something like this in contact with embassy of my country and here, and this experience will be with me forever time in my life.
There's some also connection now when you thanks for these words. Rambo Petković. Do you know who Rambo Petković is?
I was wondering when we'll come to football. Soccer.
No, of course not. But you can give me one suggestion.
Rambo Petković, he played for Vasco da Gama,
Vasco da Gama.
He played for Corinthians. I'm not sure about that. He was one of the most famous players in the history of Brazil from Serbia. Do you know that?
From Serbia, yeah.
His statue, Johan Cruyff, Zico, Pele, and Rabo Petković Pesci.
Really?
Yes. He have a record in goals from the corner. He's one of the. He's a living legend in Brazil. Rambo Petković Pesci. His nickname.
Probably,
and
he
says
he's living.
He's living in Brazil. He's a legend, and he says that it's the same, very
mentality,
similar.
maybe.
Yes,
they felt like in your home.
But legendary football player from Serbia is Rambo Petković Pesci.
Yeah.
Probably.
You ask about Pesci.
Pesci, yes.
Yeah.
So because when you mentioned you did this. Words
Feelings.
about about our similarities. I remember that Pesci also said that there is a documentary about his successful in Brazil.
But on the other hand, Brazil is so huge. I seriously doubt there's a mentality, Brazilian mentality. I think it depends. It's huge. It's huge. It's really we don't have a good perspective about the sheer enormity of that country.
Yes.
So I guess that there are different like mentalities.
Yes, we have different cultures inside of same country, but we are recognized by the Brazilian kind of to be. Brazilian jeito de ser. Okay, in Portuguese. The friendship to receive somebody, it will be the same
hospitality,
in the north or south. Hospitality, we will invite the people to come for your house. We will talk with hands and touch in the person when we are talking. Here is the same. You invite the person to go.
We are hugging with, we are drunk.
Yeah, let's go to let's talk about science and drink one beer. It's the same.
That was one of the ideas of this podcast, minus the beer, but sometimes maybe with the beer. Yeah, we had
in the last year, please, because I will be here again.
We expect the guy who is producing a beer, and the topic will be beer.
Yeah, of course.
So he says that he will bring a barrel of beer.
Please invite me for this podcast.
So this is the awesome segue, and this is basically the awesome end of the episode. So you promise you will come next year?
Yes,
and
I will.
Will be our guest, also be our guest in the episode.
Yes, of course.
Cool. Then we can talk about beer. NMR. Did you sometimes?
We have an NMR to beer, of course.
We'll leave this
we can
for
acquire
the next
the experiment.
episode.
Yes.
Bring us 300 liters.
Analyze beer
because we need that amount of sample.
Because in Brazil, of course, it's again one other forensic question. Because in Brazil, we have rules that need to be one quantity of malted cereals inside of beer to produce beer. And sometimes we don't have this. So we can use NMR to analyze the beer.
Okay.
We'll use not NMR, we'll use our tongues to
analyze
organoleptic control.
We can combine.
Yes.
Okay, thank you very much.
I like it very much. Thank you for the invitation.
Okay.
Bye.
See you.
Bye.
Bye. Awesome. Yeah.
Oh, very good. I can imagine.
We have more than 1 hour.
Really?
1 hour and 60 minutes, but maybe a little bit less.
16. Yeah, that's